5, locating and using intercepts. We're going to learn a new form. It's a form that you've seen before. They call it standard form. Try to spell out the whole word standard when you get the chance, otherwise it looks bad. So, but you will see standard form as ax plus by equals c. Now make these little annotations here. A, b, and c are just constants. They're numbers. Okay, they're just numbers. So there's your little number sign. X and y are the variables. Whatever the variables might be in the equation, x and y are the most common, so that's what they use in this standard form general. Okay, it also makes a note that a, b, and c are real numbers. We know that. A and b cannot be equal to 0. A and b cannot be equal to 0. Because if they were equal to 0, then you would end up with an equation that looks like y equals c or x equals c, and that's not a two-variable equation. Okay, so these have two variables in them. Any questions thus far? Any clarification? Okay, good deal. Let's see if I can get better lighting here. That's a little better. Okay, so when we satisfy this equation, we'll get something where it equals. Okay, so we'll find variables. So remember that anytime you get an answer for a two-variable equation, you will have two answers, and it's normally represented in coordinate form. You'll see it as x, comma, y. For example, the point 2, 3, 4, 5, or 7, negative 2. Whatever it is, it's a coordinate pair. X, y, input, output. Okay, dependent and independent. Independent and dependent is the way that one goes. So the x-intercept, let's define that. The x-intercept, this is where y is equal to 0. So as a coordinate pair, it will look like this. Whatever x is, comma, 0. Okay, for the y-intercept, it's the exact opposite. Intercept. This is where x equals 0, and the coordinate for it will look like 0, comma, whatever y is. Okay, so if I was going to draw the x-intercept, okay, if this was my x and y axis, and it had a line that was crossing through, just like that, the x-intercept is where it crosses the x-axis, right there, where it crosses the x-axis. I'm going to put a little blue dot there. On the y-intercept, okay, again, I need an x and y axis here. It's where it crosses the y-axis, so right here. Okay, it's where the line crosses the y-axis. So that's the simple definitions of it, both geometrically and with words. Mathematically is right there. Any questions on that part? Should make more sense as we get into the examples. Okay, example 1, and I will show you both a vertical chart and a horizontal chart, but we will use either one you feel comfortable with. It doesn't matter to me which one you use. They're equivalent in my eyes. So 3x plus 4y is our equation, equal to 24. Now the first way I'm going to show you is xy with a vertical chart. Okay, so in order to find the y-intercept, we would put x equal to 0. In order to find the x-intercept, we would put y equal to 0. So you set up a staggered set of zeros. Okay, and if I want to complete this box, I would just finish it out like this. Okay. So in order to finish out what's in this one and what's in this one, all I do is exactly what is said here. It says let x equal 0. So that's what I'll do. 3 multiplied by, where x is 0, plus 4y equals 24. And then I start to evaluate this. 3 times 0 is 0. right? And 0 plus 4y is 4y. And it still equals 24. Then I just finish solving by dividing by 4, divide by 4, and y then equals 6. So I go up here and I put it in my chart. Y equals 6. And I do my second equation. Again, I'm using this original here to plug in. So I have 3, and I don't know what x is, plus 4 multiplied by 0 equals 24. And I just finished solving. Okay? So, moving this up real quick. I finished solving. 4 multiplied by 0 is 0. 3x plus 0 is just 3x. And it equals 24. You're probably already starting to see an easy way to skip a few steps. So I finish solving, divide it by 3, divide it by 3. X then equals 8. And then I take my 8 and I move it to my chart, plug it in right there. Okay, so now I have two coordinate points. I have 0, 6 and 8, 0. Okay, I would graph those points on a coordinate plane, and that would allow me to see my line geometrically. Let me see if I can get this to show up correctly. Okay, so I'm going to graph 0, 6. That's 0 in the x direction and 6 in the y direction. So 0 in the x direction, I start at my origin and I go 6, 1, 2, 3, 4, 5, 6. There's 1 point. Then I graph my x-intercept. It is 8 in the x direction, 1, 2, 3, 4, 5, 6, 7, 8. And I plot that point, and I simply connect it with a straight line, and my ruler is gone. Alright, there it is. So I just connect it with a straight edge, and make sure that your line has arrows, because all lines have arrows. Okay, any questions thus far? Pretty simple stuff. Glad to know. Next one. Flip to example 2. Now, when you see standard forms, the easiest way to graph them is using the x and y intercept, because you don't have to convert anything. That's just the simplest way that I've found. So here's example 2. It gives us the equation 5x minus 6y equals 30. So I can again set up my x and y chart. This time I'm going to do one horizontally, just so those of you who like to do the horizontal ones can see it. I would still give a 0 to one of my x's and a 0 to one of my y's, a staggered set of zeros, and I would solve for the other variable. So I plug in 0 for x, and that leaves me with negative 6y equals 30 to solve. Did I confuse anybody by skipping that step? I just plugged in 0 for x and went from there. Do not forget this negative. It will change your answer completely. Divide by negative 6, divide by negative 6. That goes away. Y equals negative 5, and I plug it in. Since it was 0, I put negative 5 for the y. So 1 point is 0, negative 5. Okay? Next, I solve for the next one. Using this equation right here, I plug in 0 for y. So that leaves me with 5x equaling 30. And I solve. Divide by 5. X then must equal 6. So I plug it in. 6. And there's my second point. 6, 0. And I can graph it on a set of x and y axes. I go 0, negative 5, so I start at my origin, and I go 1, 2, 3, 4, 5 in the negative direction. So there's 1. And I go up 6, 1, 2, 3, 4, 5, 6 is up here. And then again, I connect it with a straight edge. And arrows go on lines, so we put arrows on them. Questions? Okay, these can be really quick if you know that when you plug in a 0, it's going to get rid of that term. It can be really, really, really fast. Example 3, if they just give you a graph, okay, like they do on example 3, they just give you a graph and say identify the x and y intercepts. I'm going to blow that up real quick. Then all you have to do is look at it and go, okay, where does it cross the x-axis? It crosses the x-axis. Pay attention to the interval here. This is counting by 2's. It crosses the x-axis at -2, -4. So it's at -4, 0. Remember that to define each of these, the x-intercept is where y equals 0. All I have to do is find the x. The x was -4. For the y-intercept, we're going to have to pull our chart back up here. It's where x equals 0. So it'll be 0, something else. So again, I'm counting by 2's. 2, 4, 6, and then halfway is 7. So 7. So 0, 7. And those are my two intercepts. Okay? They pretty much define themselves when you're looking at the graph. The y-intercept is where it crosses the y-axis. The x-intercept is where it crosses the x-axis. They even label it for you for ease of access. Okay. Anything I can do to help clarify that anymore? Okay. Example 4. We're getting all the way down to the end. Now this is the one that y'all guys are going to be most confused on, so please, please, please pay attention. The equation is y equals -2/3 x plus 5. It says write the equation in standard form. Then graph the equation using the x and y intercepts. So in order to put this in standard form, we need to look at what standard form is. It's all the variables on one side, all the variable stuff on one side, and all the other stuff on the other. Okay, so just constants on the right, just variable stuff on the left. So right now I have a variable on the left, and I have a variable on the right, and a constant on the right. I need to move this variable to the other side. So since it's -2/3 x, I'm going to add 2/3 x to both sides. And this is where most of you will get a little confused. You'll say, is this 1 and 2/3 xy? No, we're not multiplying. Okay? We're just adding it. And because they're not like terms, I literally just rewrite the addition down. I can't combine things that aren't the same, so I just rewrite them. And all that's left here is the 5. So now I have all of my variables on one side and all my constants on the other. Okay? All my variables on one side and all my constants on the other. This is in standard form. Now I have to do my x and y chart. So I like the vertical one, so I'm going to do the vertical one. Drag my y down too far, I guess. So I give a 0 here and a 0 there. I do my staggered set of zeros. Then I want to start solving. I'm going to do it right here. So I'm going to take my standard form, y plus 2/3. I was copying the wrong equation. Y plus 2/3 x equals 5. I'm going to start to plug in. I plug in for x first. I'm left with y equals 5. That was simple. I plugged in 0 for x and got y equals 5. So there we go. First point, 0, 5. 0, 5. That will be my x-intercept. My y-intercept. Next, I'm going to plug in 0 for y. So I have 0 plus 2/3 x equals 5. So I'm left with 2/3 x equals 5. What is the 2/3 doing to my x? What operation is being performed? Multiplication. So how do I get rid of it? Divide by 2/3. Now, really, when I'm dividing this 5 by 2/3, I'm actually doing what? Multiplying by its reciprocal. I'm going to go ahead and stick 5 over 1 so that we have that. But I'm multiplying by its reciprocal, which is actually 3 halves. And I multiply straight across, right? And I get 15 halves. I can reduce that down or just write it as a decimal. I'm going to write it as a decimal, 7.5. So I get 7.5 as my x, so I need to put that in my chart. So I get 7.5, 0. And that will be my x-intercept. So there we go. When you write these down as your answers, guys, if they say identify the x and y intercepts, you need to write x-intercept, at least the abbreviation, and then identify which one's the x-intercept. The x-intercept is where we have an x and y is equal to 0. My y-intercept is, again, where we have a y and x is equal to 0. So if it says identify the x and y intercept, you can't just give me this chart. That's not identifying them. That's writing them down, but it's not identifying them. You have to label which one's the y and x intercepts. Okay? And the coordinate pairs are written with parentheses. Without parentheses, it's just a list of numbers. If I have 0, 5, that's just 0 and 5. All right, last example, and you will be on your way. At a school play, students' tickets, so I'm going to write students right here because I know that's going to be important. Students' tickets are $5, so $5. Adults are going to be $8. I'm making these notes as I go along. It says let X be the number of student tickets, so X is the number of student tickets. And then let Y be the number of adult tickets, so the number of adult tickets. Reason it's important to identify what your variables are so that when you write your equations and you solve them out at the end, you're not looking at them going, what did that mean again? Okay, so if we identify at the beginning, we're like X is 7, for example. I don't know what the answer is. If X is 7, okay, that's 7 student tickets. I know now. All right, so it says the equation 5x plus 8y equals 400 shows that one Drama Club member raised $400 for ticket sales. So it says 5 times the number of students plus 8 times the number of adult tickets equals $400 in total made. So let's find the intercepts and explain which each of them mean. So finding the intercepts, again, I'll have an X and Y chart. My pencil will keep up. And I will split it up into a diagonal set of zeros. So I'm going to let X be 0. If X is 0, all I'm left with is 8Y equals 400. I divide by 8. And I'm left with Y equaling 50. So I'm going to plug that in my chart, 50. Next, I'm going to let my y equal 0, and I'm left with just 5x and 400. So 5x equals 400, and solve, divide by 5 on each side, and x then will equal 80. So I'm plugging that in, 80. And it says explain what each of them mean. So if I look at this first one, I'm going to explain that one first. If I look at this first one, I'm going to go ahead and explain what each of these intercepts mean. So here we go. It says 0 for x. So there are, for the, which intercept is this one? It's where x equals 0, so it's the y-intercept. So for the y-intercept, there were 0 student tickets. Sold, and 50 adults. Okay, so that was for the y-intercept. Next, I'm going to identify the x-intercepts. So for the x-intercept, there were 80 student tickets. Sold, and 0 adults. Questions there? Okay, so to identify these, we just state which one they are and then explain the numbers that we got, where they are. Now, of course, this isn't probably going to happen. We're not going to get 0 of one and a bunch of the other. These are identifying the extremes. Okay, what would they have sold if all of the ticket sales were just adults? What would we have sold if all of the ticket sales were just students? So these are just the extremes. Any questions?